we can solve a positive moment in the middle strip. So in the table we have two different coefficient. We have dead load and the live load. Our M is 0.8, so we can see in the table in case number 4. So 0.8 is S over L. So our S is 4 meter and our short span is 4 meter and long span is 5 meter. So in the table we can see a case number 4. So in a dead load, so we can see in the table dead load case number 4 is 0.039 and the live load we can see in 0.048. Okay, so we can substitute the mu of dead load is equals to 0.039 times the times W dead load, 9.0372. So this is this one. So this one, the W dead load. So and our short span is 4 square is short span squared. So our S is 4. So the answer is 5.64. So our mu positive live load is equals to 0.0481 times so 7.68. So as we can see here, 7.68 and S equals 4 is squared. 4 squared equals to 5.9. So our total of mu equals to 11.54 kilonewton meter. To be safe in lecture, so our mu actual is less than or equal pi bd squared fc prime q times 1 minus 0.59 q. So our mu is equals so our mu is 11.54 kilonewton meter. So in 11.54 times 10 over 6 is a kilonewton millimeter. And our pi is 0.9 times b or 1 meter strip is 1000 millimeter times d. Our d is 124 squared and our fc prime is 28 times q times 1 minus 0.59 q, and the answer of q is 0.03033. So our rule to solve our rule is the formula of rho q fc prime over fy. So we have a value of q, so we can solve our rho. So our rho is equals substitute the value of q and fc prime and fy. So q is 0.03033 times 28 over 350. So the answer is equals to 2.43 times 10 raised to negative 3. And use a third of rho from lectures is equals 4 over 3 times the rho 2.43 times 10 raised to negative 3 is equals to 3.23 times 10 negative 3. Our rho flexure is less than our rho mean. So our rho mean is equals 3 equals our rho mean here is equals to 3.78 times 10 negative 3, and our rho is less than rho mean because our rho mean is 4 times 10 raised to negative 3. But ECI and in ECP is always allows us to use a smaller of the two. So this is a smaller of aromin, so this is also ready to use. So using this, therefore our A is a positive rebar is equals to rho BD. So our rho is equals to 2.235 times 10 minus 3. Now it just a 3.235 right here. So just times 1 meter strip or 1000 millimeter times our D is 124. So our the answer of is equals to 496 meters squared. So convert to the 12 bar. So the area provided by 1 bar is equals to 496 squared divided by the area provided of 1 bar by 1 bar is pi over 4 times 12 squared. So 4.3856 PCS over 1000 millimeters squared. So the answer is 4.3856 pieces over 1000 millimeter strip. So converting this in spacing, the 12 rebar is 12 diameter. So we can this reciprocal 1000 millimeter strip over 4.3856 pieces is equals to 228.01 millimeter. Our provided temperature is 300. So this is one is trivial. And our spacing, so as we can see, our spacing is is less than or equal to 3T. So our S is our spacing is equals to 228.01. So the answer of here minimum is 450. So our spacing is less than 450. So this is less than 450, so we can adapt this. So the spacing of positive reinforcement is 2 to 8, and the spacing of negative reinforcement is 2 to 5. So between the two, it's impractical to adapt different spacing for different spacing negative, different spacing of positive when we are using uh, a bent bar. So meaning the spacing of this must be taken of the same. Spacing of this and the spacing of this must be taken as the same. So adapting the common spacing, so the positive spacing will round it down to the smaller, which is spacing 2 to 5.67. So no need to round down to nearest 25 because 2 to 5 already rounded off nearest to 25 millimeter. So therefore we adapt this bar as 12 mm at every 2 to 5 center throughout the middle strip. So in a column strip, the instruction of is just use 1/3 of a moment. So this one is just multiplied by 1/3. If using this, the one which rebels is a row minimum. So the one its rebel is this one. In here, to the column straight, the one that rebels is a 4/3. 4/3 from picture.